Hello everyone, I'm Shachan. Today I'm giving a presentation on optimizer queue representation using linked list for AI workflows in Java. This is a topic from the course of data structures. Well, coming to the topic, introduction to queue optimization in AI workflows. Queues are fundamental data structure used to manage task execution in AI workflows. Well, coming to into detail, uh, normally in AI, the normal workflow goes according to queues, like in a step-by-step process. Queues are correlated to a step-by-step process. These queues are fundamental data structures uh, through which task execution is achieved in this AI workflow. Optimized queue presentations can significantly increase performance and resource utilization. These optimized queue representations can help to properly utilize the given data uh, which are represented as resources and to improve performance like the speed of the handling the data, etc. The presentation explores how linked lists can be employed to enhance queue efficiency in Java AI-based systems. Well, going into detail, importance of queues in AI workflows. Queues organize tasks such as data processing, model training, and inference sequentially. Uh, Poor proper queue management ensures smooth and scalable AI application performance. Inefficient queues can lead to bottlenecks, delays, and increased computational costs. So these queues organize tasks such as data processing, model training, and interference sequentially. Also, such as I stated before, these queues in AI workflows works in a sequence, in a step-by-step process. This starts from data processing. They first analyze the data, or they read the data from the prompt we ask for, and they analyze the data they can find from the internet or the source that the AI has, and the model currently that AI uses to read the data and analyze the data and inference to in a step-by-step process. These tasks, the data processing, the model training, and the uh, giving the answer giving processes, this works in a step-by-step sequential process, which may take time. But if the proper queue management is achieved, then that can ensure a smooth process which can give a proper answer using the proper data from its source without any bottlenecks. So inefficient queues, if these queues are not arranged efficiently or properly, this can lead to bottlenecks, delays, or even increased complication costs, and we may not even get the proper answer for the prompt when given for. And coming to traditional queue implementation in Java. Java provides built-in classes such as linked list or priority queue for queue operations. These implementations are convenient but may not be optimized for all workload scenarios. Custom implementations can be tailored for specific performance scalability requirements. So there are built-in classes such as linked relation priority queue which can be used in programs to perform the traditional queue implementations. But there are there are limitations, and there are some exceptions which uh, these may not handle, such as if there is something a complex situation, these may not be their cup of tea, or these cannot be handled, they cannot handle. For those exceptional cases, uh, we have to create custom implementations of these queues to tailor to the specific performance and the requirement that the queue has, the required problem has. So these implementations, the given built-in implementations, they may be convenient, but for all scenarios, they may not work equally well. Okay, when coming to the next, why use linked list for queue representation? Uh, the previous two process we see. Oh, linked list. Linked lists allow dynamic memory allocation, reducing the need for resizing operations. They enable efficient insertion and deletion at both ends, making them suitable for queue operations. Using linked list can help minimize latency and optimize through output in AI workflows. These linked lists allow dynamic memory allocation, which means uh, the data allocation can be done in a dynamic way, reducing the need for resizing operations, like to need the time for reducing the data and compressing it, which may be reduced due to its dynamic memory allocation, uh, which may which may help the queue implementation process. These enable efficient insertion and deletion at both ends of the queue, the which may make the queue implementation very smooth and the operation without any workload, etc., inefficient workload, etc. by not causing any bottlenecks. These linker lists can help minimize latency and optimize through output in AI workflows. Okay, now coming to the next. Designing the linker list based queue in Java. Queue can be implemented using a singly linker list with front and rear pointers. Uh, InQueue involves adding a node at the rear where DQ removes the front. Proper synchronization is essential for thread-safe operations in concurrent AI environments. These in creating this linker list based queue in Java, this can be implemented using this front and rear pointers, which may require the NQ and DQ nodes. Uh, these are added in the program, which includes in from the front and rear pointer of the queue. The proper implementation and synchronization of these two must is essential, very much essential uh, to to do the proper implementation of the queue. Uh, if proper synchronization is done, then the operation is safe in concurrent AI environments too. Well, coming to the next, implementation details and code snippet. The core components include a node class and a queue class managing front and rear pointers. Example code demonstrates enqueue and dequeue methods without time, with constant time complexity. Ensure proper null checks and synchronization enhances robustness and thread safety. Well, this the core components in this queue implementation. Uh, the core component is includes a node and a class, node class, and a queue class managing front and rear pointers. These two classes are vital in controlling the previous NQ and DQ, the front and rear pointers of the queue, which we saw talked about earlier. These two classes manage the front and rear pointers, which manages the sequential algorithm flowing in the smooth operation of the queue of the AI workflow. Example code demonstrates NQ and DQ methods with constant time complexity. So these the in an example, for if we take an example, the NQ and DQ methods which are inserted in this node class and a queue class, they have time complexity in both of them. uh, so we should ensure proper null checks and synchronization between these two to enhance robustness and thread safety of this program, of this AI the workflow. Coming to performance and benefits of linker list queues. Constant time insertion and deletion improve processing speed for high throughput AI tasks. The constant time insertion and deletion, the insertion and the NQ and DQ, which we talked about earlier, which correlates to insertion and deletion processes. Uh, we should, if we maintain them to constant time, uh, they these both improve the processing speed for high throughput in AI tasks. Dynamic resizing prevents overflow issues through in common array-based enqueues. Flexibility in memory management allows better handling of variable workflows in AI pipelines. So the dynamic resizing, which we talked about earlier, the dynamic memory allocation, this prevents overflow issues in common array-based queues. Flexibility in memory management allows better handling of AI variable workloads in AI pipelines. So this flexibility, the dynamic memory allocation, uh, this handles better handling of variable workloads like the variance the variables the different variables of the very different workloads. This flexibility allows to handle them easily. For the optimization for AI workflows, incorporate thread safe mechanisms like synchronized blocks or re-entrant locked for concurrent access. Use custom mode pooling to reduce object creation overhead. Consider priority queues or multiple linker lists for task prioritization in complex workflows. We have to make sure the AI workflows are optimized and to go synchronized. We need to incorporate thread safe mechanisms such as synchronized blocks of or reentrant blocks for concurrent access, multiple access and etc. Use custom node pooling to reduce object creation overhead. Uh, the overhead issues, the object creation overhead issues, we need to use different type of custom nodes. Not a single load is not enough for the AI workflows if the scale is larger. Different things may require different ones. A normal node can handle sometimes the overhead issue, but in some cases, most of the cases, the custom node pooling is required to reduce the overhead issue. Considering priority queues or multiple linker lists for task prioritization in complex workflows. So there should be priority queues to handle the uh, prioritized data or prioritized uh, implementations, and there should be multiple ones, because single one is not should not be enough to handle the task prioritization. And real world applications and case studies. AI systems performing real time data analysis benefit from optimized linked list queues for low latency. Machine learning pipelines use such queues to manage training and inference tasks efficiently. Case studies highlight performance improvements and scalability achieved through this approach. And coming to conclusion and future directions, linked list based queues offer flexible and efficient solution for AI workflow management in Java. Further enhancement includes integrating log-free algorithms and distributed queue systems. Implementing these optimizations can significantly advance AI application performance and scalability. So this is how optimized queue representations using linked list work in AI flows in Java. Thank you for listening to the presentation.